Analyzing graphs of functions, the objective of this video is to identify lines with symmetry and even and odd functions. So we can graphically look at a graph and see whether it appears to be symmetric with respect to the x-axis, y-axis, or about the origin. However, we want to confirm what we suspect algebraically. So there is an algebraic test for each. So you want to first identify whether it would be symmetric with the x-axis. Then that means you would replace y in the function with a negative y and it will produce an equivalent equation to the original. If it's symmetric with the y-axis, then you're replacing x with negative x and it'll produce an equivalent equation. If it's symmetric with the origin, you are replacing both x and y with negative x and y and it will produce an equivalent equation. So in my first problem, it appears that I have some symmetry with respect to the origin. So I am replacing both x and y with negative x and y to see if I produce the same outcome. So negative x, negative y equals 4. And then you would want to simplify. So a negative and a negative will give me a positive. So x and y will give me the same output, same equivalent equation. So yes, this is symmetric with respect to the origin. In my next problem, it looks like this is symmetric with respect to the x-axis. So that means I'm going to replace y with a negative and see if I get an equivalent equation. So x minus negative y squared equals 1. When we simplify this, well, a negative squared is just going to be a positive. So I do end up with the same equivalent function. So symmetric with respect to the x-axis. We also have some special functions. We can have an either even function if it's symmetric to the y-axis, and if I have this condition met, meaning if I replace the x with a negative x, I still get f of x. It is an odd function if it is symmetric with respect to the origin, and if I input a negative x, I get the opposite of the function. So first you have to use a graphing calculator of some sort to graph the function. I do get some graph that looks similar to my image. So it looks like I am symmetric with respect to the origin. So now I have to do an algebraic test to see if this is true. So I am going to input my x with negative x into my function and see what is my output. So negative x cubed minus 2 negative x. So simplifying, a negative cubed will give me a negative x cubed answer. A negative times a negative will give me a positive, whatever 2x is. So because this is the exact opposite of our function, it satisfies. So this is an odd function. And this is my algebraic support. Now you try Determine whether the function is even, odd, or neither. Pause your video, try and do the problem, and then press play to see if your answer is correct. Don't forget to confirm algebraically. Do not just take a guess by looking at the graph. Pause your video now. My first one looks like it's symmetric with respect to the y-axis. So I will suspect it should be an even function. So the test for that is to input a negative x into the function and see if you get an equivalent expression. So whenever you take the fourth to the fourth power of a negative number, it's going to produce a positive. So this will be equivalent. So yes, even function is correct. My next one looks like it's an possibly odd function because it appears to be symmetric about the origin. So I will input a negative x into my function and see if it produces an opposite expression. So when I simplify, a negative cubed just gives me a negative. This will give me a positive x and then positive 3x. So it's almost all negative, but I do not have a complete opposite function. So this is neither even nor odd because it did not satisfy the test. So this is an example of why it is important to do an algebraic test, because even though it may appear to be symmetric about one of the three, it does not guarantee that it will be.